Okay, this video is about displacement, and I want to talk first of all about a one-dimensional example, and then we'll follow that up with a two-dimensional example. So to give it some context, let's make a coordinate system, just a single axis, since we're all going to be in 1D, moving in the x direction. And so let's say that we have a person that's moving, and that at time 0 they're at the position shown, and then at some later time t is equal to 1. Let's say we're using seconds. The position is here, the person is here, and then at position at some time 2 seconds, 1 second later, the person's position is here, and then at 3 seconds the person's position is there. So I have a person whose position is changing, and I'm going to now connect the changes in position by describing what's known as a displacement vector. So the displacement vector, it's a simple idea. It's a vector that points from the starting to the ending position. So that would be the displacement vector from the time interval 0 to 1. And this next vector I'm about to draw is the time, is the displacement of the person from 1 second to 2 seconds. And this next vector, displacement vector, is the displacement from 2 seconds to 3 seconds. And so a displacement, therefore, is a change in position. It has the units of meters, but it's a vector because there's a direction associated with it. And then in this particular example, the direction is to the right. Now this particular displacement example, where each 1 second interval has the same displacement both in magnitude and direction, is an example of constant, or if you will, uniform velocity. Okay, in 2D it's very much the same. So again, I can take a person for this example, and I can maybe say that at time 0 seconds the person starts here, and then the person goes from there to here in the first 1 second interval with a displacement like this, and then perhaps the person goes from 1 second to 2 seconds, makes this displacement, and from 2 seconds to 3 seconds makes this displacement. And so again, we have a motion diagram here in 2D. I'm not constrained along a line. I'm going in a two-dimensional fashion. And so as we'll talk about in class, we can then talk about the net displacement from 0 seconds to 3 seconds as being a vector, and I'll draw this one in red, that goes from the starting to the ending position. And so that would be something that looks like that. So this is the net displacement of the 3 separate displacement vectors. And you can do the same thing in 1D. The net displacement over this 3 second time interval would be, I'll draw the vector above, would be this vector right here. This would be the net displacement as well. And in either case, whether it's 1D or 2D, I'm adding all of the separate displacement vectors to get the net displacement over that time interval. So displacement is going to be one of the basic concepts in kinematics. We're going to use it to define velocity, and the motion diagrams are going to be one of the first ways we use to represent motion.